Hi. Okay, I wanted to talk about my push button switches that came in the other day. I ordered 12 of these. They're RGB push buttons, and the little circle here, which is not lit, could be red, green, or blue, or a combination of the colors. You can have like a pink or I don't know, light blue or lavender, whatever color you want to make. But it all depends what the software that's supplying the color, what it supports. So in my case, I'm using these MGP boards. Has the 16 inputs for switches, and then on the side here, this is where you end up connecting a 3-wire. It's a serial wire that will talk to all these switches. But you see, when you get the switch there, you have 2 pins, one on each side for the switch part, and then you have 4 pins in the center. One is a common anoid, and then there's a red, green, and blue connection for wires to your control board. But the thing is, I installed this little board. It's a WS2811 chip. You can buy them in a bag like that. There's 100 of them for like $11, so it's pretty economical. Just break them off, and then I use some copper wire and then just attach them that way. And so what that gives me is, well, the first thing you have to make sure when you order these switches, you have to have common anode switches. Because I originally had ordered common cathode, and that doesn't work because the little printed circuit board uses common anodes, so the switch has to have common anode, which means the common anode of the 3 LEDs that are in there are in common. They're all connected together. So by installing this board, now what I could do is just for running the LEDs, it ends up 3 wires come out of here, ground, 5 volts, and the signal, and it goes to the first board. And then if you look underneath here, there's an in. See, underneath it says ground, 5 volts, and in. And then on the other side, it's ground, 5 volts, and the center pin becomes out. So what happens is they bring this in to the other one's out, the other one's in, out, and out, and you go that way. So it ends up basically you have a bus of 3 wires going along the way, which really I'm really impressed, because I really like the fact that it uses only 3 wires to operate 3 LEDs on each. Independently, you can turn them on and off on all the switches up to. The board does 64 aspects, so you could have 21 switches. 21 times 3 is 63, and so you just have 64. So you only lose 1 LED. But 21 switches can connect to that. 21 LEDs can connect to that board using just 3 wires. Then the other thing is for the switch push button part, you end up having you can have a common between each one. Then it'll come back to the board here. You'll plug it to a ground, and then you have to run a wire from each one of the switches back to the inputs here. So the inputs are not serially connected like the LEDs, but at least you're saving a lot of wiring. Because if your switches are on the other end of the layout, and you have to bring all these wires, basically 6 wires, or you would have a common for the LED and a common for the switch. So that would be and then 1, 2, 3, 4, 5. Yeah, 6. So you would have to have the common for the switches, the common for the LED, and then the input for the switch, and then the 3 color wires for the LEDs. So that would be a lot of wires going back. In this case, you're reducing it a lot. So, and then this board has the smarts where you program it with a tablet. And let me see if the tablet is working. Hold on. Okay, I have the software running here. I don't know if you can see this. I'll call up a panel. Let me see. LEDs, LED 1. See, there's nothing set here, but what you would do, let's see how the lighting works over here. So you would say, like in this case LED 1, you would say what the address is, what it's triggering. See, LED type, so it says none in this case. I would say, hang on, tap this, none, select an option. So it's either being thrown by a switch, switch thrown, switch closed, status occupied, block free, switch, known state, switch unknown state, signal start, signal go slow, and combo active. So basically you can say, okay, yeah, I'm going to close the switch and save, and then you give the switch address, let's say 10, save, and then the intensity of the light, you can set that as a default. So then what happens is then you click on the right, and it'll write that information. It'll change from red to white because it was written to that board. And what's neat is, again, the tablet is connected to a Bluetooth interface. That is, I think I have it here. I don't know if I've shown it before. Yeah, this last thing. It's a local net Bluetooth interface. So then that guy would update those boards. So at your convenience, you can scroll through the menu and do that. So that's that. And then here is where I started installing the switches. There's two there. There's one, that green one over there. So now from my panel, if I press from another local net device, that will trigger that to turn out. So those are my routes T and U, which is those two locomotives up there. So when I need that, so if I flip on this panel here, I select route T. See, that light T will come on. I'll just put a letter under it to easy to identify it. So now if I switch to U, see, the U comes on, the T goes out. So that's for the green light. And then the other thing is, if I get there, so this is the first time, if I move the locomotive, to show that it's occupied, and if I tap it, put it down, see the light went back to red, showing that. That's because it's on the other route. Now if I do the locomotive that's in the forward, if I move him, take him off, put him back on the track, this actually goes to yellow, because the reason it's yellow is because the route is actually selected and the block is occupied. So it goes to yellow. Red means there's a train there, but the route is not selected. And so this is a combination of being red and the green signal. And so that's how I have these guys wired up now. There's a little board under there, might be hard to see, but the board is there, and then I'm daisy chaining the wiring here. Again, that might be hard to see. So that's what I've got going up to now. The other thing I have done is, let me see, I don't know if I'm gonna get some better lighting here. I actually have a Raspberry Pi in this little black box over here, and then here I installed what they call an mSATA 60 gig SSD drive. That's plugged into there, and then there's the connection to my local net, local buffer over here. So what's happening is JMRI is running on this screen here. Let me see. Here I can connect. This is actually a PC running Windows 7, but then I use a VNC connection to the Raspberry Pi, and now I see my Mac there. See here, you can see the two tracks are occupied. If I move the locomotive, there it goes. Hard to see it. Right, and then all the signals should be right, the right signal. So that's what I got going. This is my test board for some tracks. This is what they call a DCC Gen Paco Canada. He's a website, and he made this little circuit from a long time ago. I ended up making the printed circuit board, and I attached it to maybe the keypad and all of this stuff. And so basically that's actually a little command station. So what's neat about this guy is that tiny little board here is the command station, and it has a USB. You can see a USB connection there that you can plug it into the PC right there. It's a printer type cable. Now that'll go to a PC that you can run JMRI and talk to this guy and running your layout. So just this little guy, but you need a little power supply for him, like to run, because he runs on 5 volts. But you need power for your track, your layout and stuff, and that's what this power supply. But any DCC power supply will work as long as you have a DCC signal in, and then 5 volts and ground to go to this guy. Boom, Bob's your uncle. And then the other thing is it also has a network connection here, which is what they call an S88 connection. And this I bought from DBKai, an S88 decoder. So that, and then if you have more of these, they do 16 blocks. I individually set this up into 11 blocks. But if you needed more, you can just daisy chain them on, and you would end up seeing all of this on this display here. You can run locomotives, you can flip turnouts, you can see your block detection, all from this. So it's actually even better than using a DCC system, because that you need an Arduino, you need a power supply to shield it. I used to put it together pretty cheap, but then you have to rely on JMRI to connect your phone, because you don't have no way of a keypad or anything to run the locomotives. Whereas in this case, you do have this keypad there, and you have the screen there, so you don't need to have the computer control. But you could if you wanted. I even played around with. I can connect it to this JMRI that I'm running there, or you can connect it to iTrain or train controller. So that was a neat project I have playing around with that. Made a bunch of those boards. Okay, that's what I wanted to talk about. Thanks for listening. Bye bye.